Controlled Environment Plant Production Engineering Technology Education modules are developed and presented by The Ohio State University, Rutgers, the State University of New Jersey, and the University of Arizona, with support from USDA NEFA through their Higher Education Challenge Grant program. In this module, we'll discuss the topic of greenhouse site selection and layout. This module is presented by Weifang Li, Dr. Peter Ling, and Dr. Margaret McMahon of The Ohio State University. Dr. A.J. Both of Rutgers, the State University of New Jersey, and by Dr. Cherry Kubota and Dr. Jean Giacomelli of the University of Arizona. This greenhouse site selection and layout module will allow you to meet 3 objectives. By the end of this module, you will be able to select an appropriate site for a new greenhouse facility, design a greenhouse facility that optimizes material and labor flows, and discuss space utilization of several growing systems and environmental control options for a greenhouse. Layout design prior to construction is one of the most important processes to ensure a successful greenhouse operation. With a well-designed facility, you will have a smooth operation that optimizes labor efficiency, material flow, and maximizes space efficiency. You will save yourself money and trouble from future alteration. In order to have an efficient greenhouse operation, there are 3 areas you need to look at when considering the layout design from broad scope to microscope: site selection, facility design, and space allocation of interior area of headhouse and production area. To select a site, planning is important because one will remain in the same location for a long time. A wise decision on site selection will save you money and time for your operation and potential future expansion. Therefore, it is important to plan ahead with things in mind. A site with level topography, access to reliable utilities, easy access for transportation of people and materials, potential on-site expansion, and availability of environmental resources. For transport access, it is important to pick a site that is close to well-maintained roads that are free from natural obstacles such as snow and flood. This is especially important for regions that experience winter season or frequent flooding events. Snow accumulation on the road without prompt removal or a crumbled road due to frequent flooding might hinder workers from accessing the site, interfere with prompt delivery of materials and supplies, and prevent prompt shipment of finished products. Most of the greenhouse operators start small and grow every year. Make sure you start out with plenty of room so you can expand your operation when needed. Choose a site with plenty of level ground to save costs associated with altering terrain to allow for greenhouse construction. Avoid sites surrounded by natural boundaries such as streams, forests, and mountains that cannot be easily altered. For environmental resources, dependable utilities are crucial. You have to make sure you can get reliable supply of electricity, quality water, and gas all year round. You do not want to ruin your production with unexpected utility outages. Also, frequent outages will increase the load of any existing backup systems and eventually shorten the system's lifespan. You need a good drainage and sewer system that can prevent surface runoff by directing excess water away from your site. On top of those mentioned above, if you are able to identify some useful natural resources around the site, it will be a bonus. Ensure that irrigation water can be obtained from a nearby lake, river, or by drilling a well for groundwater. Look into geothermal heating, cooling, and thermal storage. Thermal storage could be accomplished by using a large body of water such as a lake, river, or aquifer. To build a commercial greenhouse facility, there are 3 fundamental components you need to consider: headhouse, production area, and retail area if the operation is retail instead of wholesale. Even though the pieces might vary depending on specific business type, the arrangement of the pieces should be considered with material flow in mind. In our case, the headhouse is the heart of these pieces, where all the materials gather at and distribute from. Therefore, surrounding the headhouse with production and retail areas is a good decision. After these 3 pieces, you might want to add on secondary pieces, such as a customer parking lot or loading zone. The loading zone needs to be close to your headhouse for easy supply of product deliveries. Your facility should connect to a well-maintained road to allow easy transport access. Additional considerations are area for production expansion and location of natural resources, such as a lake. With this, we complete the material flow idea by delivering raw materials from the loading zone to the headhouse, where raw material is prepared and sent to the production area for growing. Matured plants are harvested from production area and sent to the headhouse for packaging, and then sent to the retail area for sale or shipped out. Here is another example of a logical facility layout design involving less pieces. A simple 4-acre greenhouse facility master plan. This plan will develop a greenhouse facility in 4 phases. Phase 1 will start with a 1-acre production area, made up of 9 bays of 7.3 by 58.5 square meters of greenhouses, along with an 18.3 by 58.5 square meters area that is divided into an office that holds break and restrooms, and a headhouse that is dedicated for work and storage. Phase 2 will extend another 1-acre production area into Zone 2. Phase 3 will expand another 1-acre production area into Zone 3, along with a second headhouse and a 6.1 meter wide central walkway between Zone 1 and 3. The reason for adding a second headhouse is because we do not want to overload Headhouse 1 and at the same time can make room to accommodate workload from the next phase of expansion. At last, Phase 4 will add in a final 1-acre production area in Zone 4, and this completes the whole development. A headhouse is the hub of a plant production facility. It contains multiple activities in one place. It might contain an office for record keeping and customer receiving, a utilities room to keep the boiler and electrical panel, restrooms, and a lunchroom for employees, a control room if the greenhouse is equipped with a monitoring and control system, a storage room to store parts and tools, a cooler to store fresh flowers, fruits, and vegetables, a shipping area for order sorting and fulfillment, and a space for plant-related activities, such as growth media preparation, potting, seeding, germination, transplant, and packaging. Note that some people might exclude parts such as the office or the shipping area, or other components from the headhouse design. A headhouse does not have to include everything in this list, nor is it limited to the activities listed here. Some questions you might want to ask yourself while designing a headhouse are: where should I locate the headhouse? How much area is sufficient for a headhouse? How should I arrange the components inside the headhouse? Here are some guidelines for you to think about. The recommendation on headhouse placement is different depending on your operation size. For a small operation, you can prioritize on maximizing sunlight in the greenhouse areas for plant growth by placing your headhouse at a location where shade won't be formed on your greenhouses. In a northern region such as the United States, it is recommended to place the headhouse to the north of the greenhouses, as the solar angle is south throughout the year in the northern hemisphere. Conversely, in southern regions, where the solar angle is north, the headhouses should be positioned to the south of the greenhouses. For a large operation, it is better to prioritize on minimizing materials transportation time rather than increasing sunlight allowance into greenhouses. A centralized headhouse among greenhouses would minimize traveling distance between headhouse and production areas, which in the end will save you a lot of time on moving around. For the floor plan, it is important to maintain a logical flow from material in to product out to avoid traffic jams, bottlenecks, and unnecessary movement to be labor efficient. As for the area, in order to have enough space to work in, Greenhouse Engineering book recommends the area of a headhouse to be at least 10% of total growing area. Also, one thing to keep in mind is allowing for room expansion. Greenhouses usually do not contain many components. Because greenhouse space is expensive, the maximum possible growing space should be utilized. However, workers need to access the plants for cultivation activities and to move the plants around. So it is unavoidable to include walkways in the greenhouse. This image is not to scale. The purpose here is to illustrate that there should only be two things in the greenhouse: the plants and a minimum amount of path area to efficiently access the plants. The less walkway, the higher the space utilization efficiency, and the less access to the plants. The exact space efficiency of various growing area and walkway designs will be discussed later. Most conventional greenhouses are elongated shapes to minimize construction of labor-accessible pathways. Therefore, the orientation can be categorized into either east-west or north-south. As you can see from the diagram, east-west oriented greenhouses have more solar receptive surface during wintertime when solar angle is low. The winter sun shines through a sidewall. More plants are located close to a sidewall compared to an end wall, so low winter sun will reach a maximum number of plants. Sidewalls are also typically clear of light obstructions, while the end walls usually have vents, cooling pads, heaters, and doors. The biggest drawback for this orientation is the uneven light distribution within the greenhouses. In the morning and evening, the sun is shining through the end walls where obstructions are located. As the sun passes over the roof, structural obstacles that run the length of the greenhouse, such as gutters, will cast stationary shadow patterns on the plants below. Now let's examine north-south oriented greenhouses. As you can see from the diagram, the benefit of north-south oriented greenhouses is the even light distribution on the plants throughout the day as the sun moves from shining in the east sidewall to over the roof to in the west sidewall. However, one of the drawbacks is that it captures less winter sunlight where the solar angle is the lowest in the wintertime, as most of the light shines through the south end wall. Fewer plants can be located close to an end wall than a sidewall, so light shining through the end wall will reach a minimum number of plants. In addition, end walls typically have obstructions that block light. North-south oriented greenhouses will be more beneficial to summer gardening where the solar angle is high, and east-west oriented greenhouses will be more beneficial to winter gardening, where the solar angle is low. When designing a greenhouse for a new business, how much growing space will you need? For the floor area, Greenhouse Engineering Book recommends a minimum starting area of 232.3 square meters for retail operations and 464.5 square meters for wholesale operations. Always remember to leave room for expansion. The recommendation is 2 times the starting area. When designing a greenhouse for a new business, it is important to determine if this is to be an income supplement or a full income. The 1 acre rule of thumb works well here. Greenhouses less than an acre are typically supplemental incomes for families. Greenhouses larger than 1 acre typically have professional employees and can be a full income by themselves. Please keep in mind that this is only a rule of thumb and does not work well with high-value crops where less space can make more money. For the floor plan, you need to get the most out of the space you have. At the same time, you need to allow labor access by maintaining a walkway so that workers can perform plant care activities such as watering and chemical application. For a larger operation where heavy-duty machines, such as harvesters and weightlifters, are involved, you need to make sure your pathway is strong enough and wide enough for the machines to travel in and out. Moreover, depending on the growing systems of your choice, such as floor, bench, or hanging basket, and the environmental control systems, such as heating, cooling, dehumidification, and air circulation, the arrangement of all these components could be different. The key idea of designing a floor plan for greenhouses is to make it material flow and labor flow efficient, so that no time is wasted waiting for one task to be done before you can start another. After choosing the right location for a new greenhouse, we need to look at space layout inside the greenhouse itself. There are 2 things to keep in mind. We want to maximize space utilization since greenhouse space is costly, and we want to optimize labor efficiency. After knowing the type of plants you want to grow, the key consideration will be selecting growing systems that suits your plants and the potential mechanization. We are going to discuss the spacing and labor efficiencies of traditional growing systems, which include floors and fixed benches, and the mechanized growing systems, which include movable benches and movable hanging baskets. In the next few slides, we are going to show you spacing efficiency examples of some popular growing systems, regardless of their benefits or weaknesses on other aspects. These examples include growing on the floor, 2 types of fixed benches, peninsular and longitudinal style, as well as 3 types of mechanized movable benches, peninsular cranking, longitudinal cranking, and portable bench tops. One thing to keep in mind is that space utilization efficiency is not the sole criterion to select a growing system for your greenhouse operation. There are many different growing systems we can use in a greenhouse other than those listed here. Different systems give you different spacing efficiencies. Although one system might be more efficient than the other in certain greenhouse designs, the system might not be suitable for the types of plants you grow. Therefore, the usability of a growing system cannot be judged only by its spacing efficiency, but also their benefits and concerns on environmental influences, irrigation, pests, plant relocation, labor accessibility, spacing flexibility, and more. There is no one perfect way to grow one type of plant. Your judgment and evaluation of the site, including but not limited to structure, local weather, environmental control systems, and so on, is important to determine an appropriate growing system. Here are the space efficiencies of several growing systems. The spacing measurements shown here are done in a greenhouse with a floor area of 6.1 meters by 30.5 meters, which is equivalent to 20 feet by 100 feet. In these examples, the space utilization efficiency of floor growing with one aisle is 90%. Peninsular fixed benches is 71%. Longitudinal fixed benches is 68 to 73%. Peninsular rolling benches is 82%. Longitudinal rolling benches is 84%. And movable tables is 84%. These numbers are calculated based on reasonable setup in this particular greenhouse. Your greenhouse shape, bench size, activities, environmental influences, and so on might affect your system arrangement and thereby affect your spacing efficiency. The space arrangement of the first example is a floor growing system. A floor growing system with one 2-foot aisle in the center will use 90% of the greenhouse space for growing. Here is a picture of a floor growing system with hanging baskets. No benches are used. Floor growing is flexible with respect to plant spacing. However, it is not very labor efficient because workers have to bend down to reach the plants, and this makes it more difficult to relocate the plants. A peninsular fixed bench system has two 2 by 100-foot benches sitting against the long walls, and 26 6.5 by 6-foot benches sitting against the 2 by 100-foot benches, while evenly spaced 1.5 feet away from each other. 2 1 by 6.5 foot benches sitting against one of the end walls, and a 3-foot aisle in the center utilizes 71% of the greenhouse space for growing. Here is a picture of peninsular fixed benches. This bench system is not flexible on plant spacing. However, it is slightly more labor efficient than the floor system because the plants are at working level, eliminating the need for workers to bend at the waist. One type of longitudinal fixed bench setup, shown here, has two 3.5 by 100-foot benches sitting against the long walls, and two 3.5 by 94-foot benches sitting in the middle of the greenhouse that have a 3-foot aisle at each end. The 4 benches have 2-foot aisles in between each of them. This setup uses 68% of the interior space for growing. Another longitudinal fixed bench setup has two 3.5 by 100-foot benches sitting against the long walls, and one 8 by 94-foot bench sitting in the middle of the greenhouse with two 3-foot aisles at each end. The 3 benches have 2.5-foot aisles between each other. This setup uses 73% of the greenhouse space. Here is a picture of a longitudinal fixed bench system. With movable benches, a peninsular cranking bench setup has 32 8.5 by 6-foot benches sitting against the 2 long walls. There is a 4-foot wide temporary aisle in between 2 benches on both sides, and a 3-foot permanent aisle in the middle. This setup uses 82% of the greenhouse space for growing. A longitudinal cranking bench setup has two 3.5 by 100-foot benches sitting against the long walls. It has 3 3.5 by 94-foot cranking benches in the middle of the greenhouse that leave a 3-foot aisle at each end, as well as a 2.5-foot wide temporary aisle between 2 cranking benches. This setup uses 84% of the greenhouse space for growing. Here is a picture of a mechanized bench system. Longitudinal cranking benches. The cranking system uses the cranking mechanism to limit the walkway to one temporary shiftable aisle. where you can shift the benches from side to side to expose a single aisle in between. This system improves spacing efficiency from a fixed bench system. A portable benchtop setup has 14 10 by 6 foot benches filling up the whole greenhouse, except 6 foot wide temporary aisles and a 2 foot wide aisle at each end of the greenhouse. As you can see on the diagram, the portable benchtops can be moved horizontally to the ends of the greenhouse and then vertically out of the greenhouse. This setup uses 84% of the greenhouse area for growing. Here is a picture of a portable benchtop system. This system mechanizes the moving of benchtops so that it not only improves spacing efficiency compared with a fixed bench system, but also improves labor efficiency by enabling benchtops loaded with plants to be easily transported into or out of the greenhouse. Furthermore, with a network of tracks constructed, you can effortlessly transport the bench and plants throughout the entire production process, from seeding to growing area and from growing area to shipping area. This will save you labor force and time on transportation. There are several ways to create additional growing space in the greenhouse. Overhead and vertical growing are the most popular ways to do it. However, due to shading effects, these systems could be limited to certain types of plants or lighting conditions. The most popular overhead system would be hanging baskets, while the most popular vertical growing system could be the A-frame. Although there are different varieties of systems out there, the concept is still the same. We make use of the space above the ground or benches. Here is a picture of a mechanized hanging basket system. The mechanized hanging basket not only extends space utilization in a greenhouse, but also improves the labor efficiency. The moving mechanism of this system brings the baskets to you or away from you. Therefore, workers can stay in one place to finish loading and unloading or managing the plants without traveling all the way down to the other end of the greenhouse. Here is one variety of the vertical stackable concept. The plants are grown on the floor and on portable bench tops. The plants on the floor remain in the greenhouse for the whole time, while the plants on the bench tops are moved outside of the greenhouse during the day for crop hardening. Then, at night, they are rolled back into the greenhouse. This type of setup doubles the space efficiency. However, it is limited to certain types of plants and your growing practice. Here is another look from inside the vertical stackable greenhouse. There are the plants growing on the floor inside the greenhouse, while the bench tops are rolled out during the daytime and would be rolled back into the greenhouse at night. There are other small things that might affect the spacing and labor efficiencies in a greenhouse layout design. Something like building a concrete floor for a cart or maybe machine access might influence your decision on spacing, infrastructure, and growing system designs. The picture here shows a nice wide concrete floor for cart access. Easy access is important. You do not want to maximize your space utilization while increasing labor access difficulty. The picture to the right shows a long, narrow path that workers must walk and carry plants by hand. Logical traffic flow is important to improve labor efficiency as well. In conclusion, when you are ready to start up a greenhouse production business, other than your decision on business type, you should also plan ahead by selecting a site, designing the facility layout, as well as designing interior spacing of headhouse and greenhouse with transport accessibility, future expansion, material flow, and labor efficiency in mind. Thank you for viewing.